Okay, hello, how are you? Sorry about my voice today. We're going to be looking today at Chapter 7, Topic 2, and we're going to be looking at the relationship between the mean and standard deviation. But first, let's just spend a little bit more time talking about the standard deviation and in a different example. In our first example today, we're looking at shooting percentages. These dot plots show the distributions of shooting percentages for 30 NBA teams in the 2009-2010 season, and then for the 252 NBA players in that season. Obviously, this is the one with the 30 teams. This is the one with the 252 players. And this question is asking which one has a larger standard deviation. And we discussed in the last lesson that we can look at what has a larger which one has a larger standard deviation by looking to see where the values vary more from the mean. And so obviously if we look at the team's shooting percentage, their mean is about here, and then our spread is not as big as that for the player's shooting percentage. So we can say that the player's distribution has the larger standard deviation. And statistically, we can say that that's the case because the data values vary more from the mean. Or you could say the data values are farther from the mean on average than the teams. Okay. Another thing that we did is we talked about interpreting our standard deviation. And it gives us the distribution, it gives us the standard deviation for the team shooting percentage. It says the distribution of shooting percentage for teams has a standard deviation of 1.5%. And let's interpret that value. Remember, standard deviation is the typical distance that performances are from the mean, from the ability. So it's a typical distance, so we'll start with typically. And what we're looking at here, the statistic that we're dealing with is an NBA team's shooting percentage. So we'll put that here. An NBA team's shooting percentage. Okay. So that type of performance varies about 1.5% from their ability. So again, on average, we would expect shooting percentages for teams to vary from their ability, to vary from their average by about 1.5%. And what that means is that if this is our middle, we would go over about 1.5% to one side, 1.5% to the other side. And again, most of the teams fall within that range. Again, typically an NBA team shooting percentage performance varies about a 1.5% from their ability. The next thing asks us to estimate the standard deviation for the distribution of shooting percentage for the players. Now, I don't know exactly what this is, and I don't want to put all these values in my calculator. So this is how we could do that. What we can do is we know that standard deviation is in relation to the mean. So why don't we estimate where the mean of this is? If I look at the player's shooting percentage, I look at the mean, I think the mean might be about 45-ish. So I'm going to say that the mean is about 45. And the unit that we're dealing with here is percent. Let me zoom a little bit. Oops, sorry. Wrong button. Okay, I'm not going to zoom out. Okay, we just have to deal with it. Sorry. So the mean is about 45%. Then the next thing we do is we look for an interval above and below the mean that covers about 2/3 of the data. Okay, so let's say that we said, let's go 10 units above and below the data. If I went 10 units above, I would be going all the way to 55, and 10 units below, all the way to 35. Now that covers a lot of the data, and actually, to be honest with you, that covers almost too much of the data to be considered a standard deviation. Again, we want it to cover about 2/3 of the data. This looks like it covers more like 90% of the data, right? So if I look at plus or minus 10, notice that this is too big of a standard deviation because it covers too much of the data. So that is not going to work out. Well, let's say someone said, let's try plus or minus 1. That means that I would go 1 unit to the right and 1 unit to the left of 45 and include that. Now, again, this is supposed to be 2/3 of the data. That's not enough, right? That's not even half of the data. So if I went 1 away, that's too small. So I want you to look at this and think, how far from the mean in a positive and negative direction do you think that we would go to cover about 2/3 of the data? And sometimes people say maybe about 5%. If I went 5% above, that would bring me to 50. 5% below would bring me to 40. That looks a little more like 2/3 of the data. Maybe it's like 75%, so maybe you'd want to go plus or minus 4 instead. But what I see is that plus or minus 5 looks pretty good. It looks like it's about 2/3 of the data. So that means that our standard deviation is going to be about 5. And then the unit that we're dealing with here is percent. Okay. So again, it's not always percentage, but again, that percentage is coming from that unit. Okay. So that's how you can estimate the standard deviation of a specific data set. So now that we've reviewed standard deviation a little bit, we're going to look to see what doing certain things to data does to the mean and the standard deviation. Okay. So if we add an additional value to our data set, summary statistics like the mean and the standard deviation can be affected. And let's talk about how that can happen. Let's talk about the mean. The mean is an average of the values, so that means that the new data point's position relative to the mean will tell us what will happen to the mean. So if we add a value above the mean is also going to increase. And if you add a value below the mean, then of course the mean is going to decrease. Okay. Okay. So if you add anything above the mean's going to go up with it. If you add anything below the mean's going to decrease with it. Now, standard deviation, on the other hand, is a different story. Since the standard deviation is an average of the distances from the mean, the new data point's proximity to the mean, that means how close or how far it is to the mean, will tell us what happens to the standard deviation. So if we add a value that's close to the mean, and by close to the mean, I mean less than 1 standard deviation away, that means that the standard deviation should decrease. Again, if I'm adding something closer to the mean that's within 1 standard deviation, the typical distance decreases. However, if I add a value far from the mean, which is more than 1 standard deviation, that means that the standard deviation is going to increase. So if my standard deviation was at a certain spot and I add something outside of that spot, now the typical distance has increased as well. And so we'll practice that in this next example. It says, suppose we added 1 additional player who had a shooting percentage of 35%. How would this affect the standard deviation? Well, remember we had said that we thought our mean was 45, and we assumed that our standard deviation was about 5. So that's kind of what we're thinking about our typical distance. Well, what we're doing here, however, is we're adding another player. We're adding a player that had a shooting percentage of 35%. So if I look at that shooting percentage of 35%, that means that I would be adding a data value here. It says, how will this affect the mean? Well, we look at its position relative to the mean, and the mean was 45. So I see that this value is below the mean. And because the value is below the mean, that means the mean is going to fall as well. The mean is going to decrease. But now let's think about what happens to the standard deviation. How it affects the standard deviation is we look at the proximity to the mean. Is it close to the mean or far from the mean? And by close to the mean, we mean within one standard deviation, and far from the mean is more than one standard deviation. Well, look, this was outside of those boundaries that we set. So this is greater than one standard deviation. Because it's greater than one standard deviation, that means that this value is far from the mean. So that means that the standard deviation would increase. You guys, I know it's a low data value, but now that we added this value that was far away, now the typical distance from the mean has increased as well. Okay. Let's say that we add another additional player, a different player, and let's say that had a shooting percentage of 47%. So 47% would be, I don't know, maybe about right here. Okay. So here's our player with 47%. Notice that this value it's close to the mean, but as far as in relation to the mean, it is slightly above the mean. So I'll say, okay, this value is slightly above the mean. Then that means that the mean is going to increase slightly. If you said stay about the same, I get it, because that's one of 252 values. That's probably not going to make that much of a difference, but ever so slightly, because it's above the mean, it would probably increase a little bit. Okay. But now when we ask to see how it would affect the standard deviation, we look to see its proximity to the mean. Do you see that this 47 is like between the original standard deviation? So that means that the mean is less than one standard deviation from the mean. That means that the value is close to the mean. And because the value is close to the mean, that means that the standard deviation would decrease. Okay, so I have these prompts here in our notes to kind of show you that's how your sentences should look. When the problems ask us how it affects the mean and the standard deviation, try to model them like these sentences are here. Okay. So the next example is example 2. It says, use the data below regarding runs scored by the Detroit Tigers in the last 30 games of their 2019 season. And it's asking us to make a dot plot of this data. Remember, when we make a dot plot, that means that we're going to have a dot for every single one of these values. The lowest value I see is 0. And the highest value is 12. Did I leave you enough spots? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good, I did. I'm going to label this as runs scored. And I'm even going to give it a title right away. So this was the Detroit Tigers. Last 30 games of 2019. Okay. And now we can make a dot plot of that data. So let's just take a second and put a dot at all of those values, for all of those values. I'm going to pause. You guys can pause the video and do that on your own real quick, okay? Okay, so here's what mine looks like. That's what my dot plot should look like. And again, notice that as we did before, we labeled the axis and we gave it a title. So this asks us to find the mean and the standard deviation of our data set and to round our answers to the nearest hundredth. Well, what we know that we can do is we can put all of these values in a list and we can find the mean and standard deviation that way. So let's do that and see what we get. One sec. Okay, so after I put those in the calculator, I'm seeing that my mean is about 3.63 and my standard deviation is about 2.79. So we'll just make a little note of that that's going to be our mean and standard deviation. So our mean is about 3.63 runs, and our standard deviation is about 2.79 runs. Remember, we look at the S sub x. And we rounded our answers to the nearest hundredth, which was 2 decimal places. Okay. So the next question says, what percent of the data falls within 1 standard deviation of the mean? So to do that, what we're going to do is we're going to take the mean and add and subtract a standard deviation. So we're going to take the mean plus a standard deviation, which is about 3.63 plus 2.79. And then we can take the mean minus the standard deviation, which is 3.63 minus 2.79. When we find what those are, this ends up giving me 6.42, and this ends up giving me about 0.84. Okay. It also asks us to mark these boundaries. So my 6.42 is going to be about right here, and my 0.84 is going to be about here. Okay. Next, I want to know how many, again, we're looking at the percent of the data that falls within 1 standard deviation of the mean. So how many dots fall between those values? And if I count the dots between the values, instead, I'm going to count the ones that aren't in the values, 1, 2, 3, 4, 5. So if there were 30 games and 5 are not in the values, then that means that 25 are actually between those values. And then I'm going to divide by the total. I had 30 dots total, so I can have 25 divided by 30, and that's going to give me about 83.3%. So those are the steps that you do. Basically, you just use the mean and the standard deviation to find the boundaries that are within 1 standard deviation above and below the mean, and then we just count how many are between and divide by the total. So the next question is saying to find the percent of data that falls within 2 standard deviations of the mean. And so if I want to find what's within 2 standard deviations of the mean, what I'm going to do is I can either take the mean and add 2 standard deviations, or we can take the previous boundary and add 1 standard deviation. So what I could do is I could take that 6.42 and I could add another 2.79, and I could take the 0.84 and then subtract another 2.79. So that's what I did here. I decided to take the previous boundaries and just put another standard deviation on top of that. Well, that gives me about 9.21 and negative 1.95. And I'm going to mark those as well. So negative 1.95 will be over here, and 9.21 is going to be about right here. Okay, so I do those and I'm going to mark those boundaries. Now I count the dots between these boundaries, and I see I only have 2 that are not within the boundaries, which means that 28 are between the boundaries. So I'm going to take 28 over 30, and I find that 93.3% of this data is within 2 standard deviations of the data. Okay, so for those questions, I'm going to be looking for 3 different things. I'm going to be looking for your boundaries, the number that you counted between, and then dividing it by the total to find the percentage. So again, the boundaries, the number that you are dividing by the total, and the percentage. Those are things I'd like to see on the homework, okay? All right. So let's suppose that we added 2 runs to each of the runs scored to the 30 games above. What effect does that mean? What effect does that have on the mean and the standard deviation of the runs scored? Well, in something like this, we're adding 2 runs to every single one of the runs scored. We're not adding one additional value. We're taking all the values and changing them. And we had a problem like that in the notes the other day. What happened is that the mean did change. How would the mean change? Well, the mean would increase by that specific value. The mean would increase by 2 runs. But do you remember what happened to the standard deviation? Our standard deviation would remain the same. And that's because all of the values, even though all the values are changing by 2, they're all increasing like the same amount. They're all increasing a certain amount, that same amount, so the spread stays the same. And speaking of the spread, what effect do you think adding 2 runs to each of the runs scored to the 30 games have on the range and the interquartile range? Well, aren't these also measures of spread? So the spread isn't changing. If you're changing all the values, your spread is staying the same. So let's make a note of that. We'll say since, like the standard deviation, these are measures of spread, the range in IQR would stay the same too. Okay. Again, what's happening is that these measures of spread, they're all just shifting by the same amount. So since they're all just shifting by the same amount, the spread isn't changing. The spread is staying the same. Okay? So, a little caution about the influence of outliers. One thing is that excluding an outlier can affect the standard deviation. We said in our last chapter that outliers also affect the mean and the range. But outliers can also affect the standard deviation. Okay? And this is asking us if there are any outliers in this data that we have. And we'll show work for that. So to find our outliers, what we'll do is we take Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR. Now, I'm telling you that Q1 is 2 and Q3 is 5. So what that means is that my IQR is going to be 5 minus 2, which is 3. So then I can just put these values in. 2 minus 1.5 times 3, and then 5 plus 1.5 times 3. And then this gives me negative 2.5 and 9.5. So what that means is that anything between these values is okay. Anything outside of that is going to be an outlier. Looking back at those at that data, do we have any values that are outside of that range? Well, we don't have any values less than 2.5, but we do have 2 values bigger than 9.5, 10 and 12. So again, remember that this represents a range of acceptable values that are not outliers. And so what that means is that we do have outliers of 10 and 12. Okay. So now that we know that, let's say that one of the games, something happened and they decided that it was a mistake. How would, and this is different, and on the last page what we did is we were inserting different values. On this question, what we're actually doing is we are removing values. How would removing 12 from the data affect the summary statistic? Well, let's think about what 12 is. that 12 is a high and far away value. In relation to the other points, 12 is above the mean, and it's way outside of 1 standard deviation. So let's say that we took 12 out. Again, what this means is that we are removing a high value. So what would that mean about the mean? Well, if we're removing a high value, the mean would decrease. Again, we're removing a high value. What would happen to the range? Well, if we took 12 away, now our values are closer together. So our range would decrease. Okay, again, we're removing a far away value. So notice that when we remove values, like the opposite happens from when we put them in. And so the same with the standard deviation, because we're removing a far away value, now our values are now closer together. So our standard deviation would decrease as well. And again, that's because we're removing a far away value. Okay. So now think about, and so pay attention to that in the homework if they're asking you if you're putting the value in or if you're taking the value out. Okay. So let's try this one. Even though it's not an outlier, how would removing 0, and I know there were 2 of them, how would removing 0 from the data affect these summary statistics? Okay. And while you're thinking about this, I want you to remember that 0 is a low value. And if we look back at 0, 0 is also outside, 0 is outside of that 1 standard deviation. So 0 is also considered a far away value. Okay. So let's say you took out those zeros. How is that going to affect these summary statistics? Press pause and see if you can figure it out. Okay, so I don't have all the answers here yet, but I wanted to kind of make sure that we're processing it correctly. If we're removing a low value, now what that means is that the values are on average going to be larger, so our mean would increase. 0 was more than 1 standard deviation away, so that's considered far away. I know 0 is not that far from 4, but because it was more than 1 standard deviation, we're going to consider that for our purposes far away. So because we're removing this value that's far away, now the values are closer. So that means that our range would decrease. And the same thing is true for the standard deviation. The standard deviation would decrease also because we're removing that far away value. Okay. So again, today in the assignment, just make sure that we're trying to be very specific. Remember, don't just say increase, decrease. Make sure that you're talking about why you're choosing that, and pay attention to if they're talking about adding a value in or taking a value away. And you can use sentence structures like this to kind of help in your explanations as well. Okay. All right. Have a wonderful day. Take care.